Hi, all. I welcome you to the Building Culture podcast where I invite incredibly smart people who build things. Whether they be engineers, entrepreneurs, programmers, hobbyists, or researchers, it does not matter. As long as you're someone who's passionate about building things, I'll find you and podcast you. Hi, all. I want to take a brief moment to thank you all personally for supporting this podcast on YouTube and on all major podcast platforms, including Google Podcasts and Spotify. The podcast mainly features interesting people in robotics, artificial intelligence, and entrepreneurship. If you believe that the information that I'm providing might be of benefit to you or to someone you know, it would be really great if you could hit the subscribe button and press the notification icon so that you can get notified on time whenever the next part is out. It would literally take you a second or two to subscribe to the podcast, but it would really mean a lot to me because I can grow the podcast to a level where I can reach more people, invite ever more interesting guests, and have a more meaningful impact. So let's begin now. Interesting. Now let's talk about autonomous driving, and we can go into
Sure.
more details about that as well. So first of all, can you give a general overview of the autonomous, technology that is available worldwide, where we are, right now, and what's the ultimate goal? Can you also briefly explain the levels, level 1 to 5, just a general overview of autonomous vehicles?
Sure. Autonomous driving, as we know, like today, if you talk about where we are today in terms of the level of technology, we are at SA. Most of the companies in the world are at SA level 3. They may say they are level 4, level 5. They are not. I mean, clearly they are not. But again, level 0 is like where, human being drives a vehicle. Level 5 is you remove all the, actuators from a vehicle because you are sure that the vehicle would be able to deal with any kind of environmental and traffic scenario. So that's the eventual goal of autonomous driving technology. Level 4 is like you can handle most of the situations, most of the environmental and traffic situations, but there would be some very corner cases where a human being will have to take control of the vehicle. So that is that's the most difficult part. Is level 3, level 4 are pretty clear, but the distinction between level 4 and level 5 is a very hard one, because what defines a corner cases, what situations you consider to be very tough situations. So no one has defined these situations, that this situation stuff, if your vehicle solves this, then this is at level 4. If you're not able to solve this, but it's still it is level 4. So distinction between level 4 and level 5 is the toughest one to make. Level 3 is kind of okay. For example, your vehicle can navigate autonomously on relatively sparse traffic, on your less cluttered roads. It can do highway cruise autonomous driving. It can also do urban autonomous driving in some limited manner. Level 2 is mostly some ADAS related controls. For example, assisting lane keeping, autonomous braking. There can be intelligent or autonomous braking as well. For example, we have already worked on that actually, where you take the dynamics of the vehicles into account, and then you do not just regular stopping condition based braking, but you also take the control of the steering into account to actually get a much larger reduce the what we call inevitable collision state, reduce the area of the ICS basically, or reduce the volume of the ICS. These are some of the things that are part of level 2. Level 1 is mostly reverse parking assist. For example, this or that XYZ alert about lane departure and all these things. These can be part of level 2 as well. And level 0, as you all understand, is pure human driving without any assist from any computer system or any software for that matter.
Okay, thank you for explaining the different levels of autonomous vehicles. Now, my question to you is, what is the level that the European automakers and companies like Tesla, which is leading in autonomous vehicle technology, which level they are at, and when do we reach a level 5 autonomous? When do we reach the level 5 in autonomous technology? Because the Elon Musk keeps on claiming that we'll reach a level 5 in this technology in the next 1 year. He makes these ridiculous claims every now and then. So what is your view as an expert in this area?
So I think, as I already mentioned, I think most of the companies are at level 3 right now, including all the European and North American automakers. I mean, even the leading startups in this business are in level 3. I mean, just to give you an idea, for example, but include Tesla in particular. Tesla has just launched an autopilot system, right? So they have not launched even a full-fledged autonomous driving technology on the market. So on what basis is the claim that they are going to achieve not just level 4 but level 5 in 1 year? Level 5 is like you remove all the controls, right? So I mean, to give you an idea, for example, even when you look at companies like Waymo or other prominent companies in this business who are actually doing demos day in and day out, I mean, if you look at where they are doing demo, they are doing in pretty much empty streets, right? In very easy traffic. So when you ask a question about level of autonomy, you always have to focus on the dynamics of the traffic where the testing is happening, right? And if you look at all the popular demos by all the popular startups and companies in the world, they are testing the technology in very, very, very structured traffic dynamics, and even in that structuredness, their environment are very sparse. I mean, look at Waymo where it is testing almost on empty street. So, for example, I can remove all the controls from all the vehicles, and I can test a vehicle on empty street. Would you call it level 5? I mean, for the sake of calling level 5, yes, we can. But from a technology point of view, I mean, it's a pure, it's a very common sense as well that has to, for example, if you want to build something, right, for a particular condition, you have to test that in conditions that are 10 times much worse. Most of the automakers, most of the startups are solving the problem for structured traffic dynamics, taking the structured traffic dynamics into account. And that is the reason why they're talking about the corner cases, the edge cases, and all these things. So why we are focusing on Indian traffic dynamics and Indian roads as of now? Because let's suppose your goal is to make level 5 autonomous driving technology for North American or European, traffic conditions. If you can test that and verify the safety in the traffic dynamics that India offers you, you have already proven the point, because you have tested that in much, much, much worse traffic dynamics. Even if let's talk about, perception technology, right? For example, for a vehicle to achieve level 5, your perception technology also has to, support that, support all the planning algorithms. Now, if you can just, for example, I mean, okay, let me give you a very brief idea how autonomous driving works. Autonomous driving has 3 key major algorithmic pipelines: perception, planning, and localization. A set of all algorithms that process the sensory data, build a 3D representation of the world around a vehicle. We call them perception algorithms. Simultaneously, localization algorithms process the integrated sensory and the odometry data to know where the vehicle is on planet Earth with global accurate with global accurate positioning model with very high precision against some high fidelity maps which you have pre-computed. Then once you know what is around you, where your vehicle is, then the next step is to plan. So the planning and decision making algorithms are concerned with the motion and behavior planning of the vehicle on road. And this is what you have to, I mean, the planning algorithms are the crux of, achieving level 5 autonomy. Because you really have to have that much of, robustness in your decision making planning algorithms to plan the motion and behavior through, cluttered stochastic traffic conditions. Now let's take perception and planning. This is what Google pioneered. This is not pioneer by Google, but anyway, like Google is a first mover actually in a autonomous driving business. So and they adopted the model of global accurate positioning of the vehicle. So before a vehicle navigates through an environment, the entire environment has to be mapped. So the next time your vehicle goes through that environment, you again take the sensory data, odometry data, match it with the pre-computed maps that you have, and we call them high fidelity or high definition maps. This matching process, the algorithms that are involved in this inference computation, these are non-real-time algorithms. These are very compute-intensive algorithms, and you cannot do that computation using the onboard computers that you have inside the vehicle. So that is why you need to have a remote server where these computations can be done, and the results are projected back on the vehicle. Now, apart from knowing, why is it important to know where the vehicle is on planet Earth with such a high precision, 5 to 10 centimeter accuracy? Okay, this is why. Detection of delimiters, the easiest to understand aligned delimiters are road boundaries and lane markers. it is very difficult to almost always detect delimiters on road. I mean, we are just talking about the detection, just the perception problem. We're not even talking about planning. Just detection problem is so hard that you cannot do it reliably in real time using the onboard algorithms that you have inside the vehicle, right? So you need a reference map. What if your lane marker is faded? What if your road boundaries are blurry, right? Your cameras doesn't pick, the road is level, so the lidar also doesn't pick the road edges and everything basically, right? In that case, if you can globally accurately pinpoint this is where your vehicle is and this is the configuration, your pitch and roll of the vehicle. Now the maps that you have built, you can project the information stored in the high fidelity maps on the vehicle's current configuration. What information do you project? Lane markers and road boundaries, right? These are the two most important information. If you look at entire Mobilize REM chip, what it does, it projects the lane markers and road delimiters on top of vehicle current position. Why Google uses high fidelity maps? Why 5 centimeters? Because if you are 5 centimeter accurate in positioning and yaw, pitch and roll, I mean, even in that you are very accurate. You can project the information. This is how, even if your onboard algorithms fails to detect where the lane markers and road boundaries are, your vehicle knows where it is. So just consider, detecting in structured environments is so hard, let alone planning problem, right? So the world at large has not even built a tech that can robustly detect delimiters on road. You have to rely on high fidelity maps and high definition maps from legal standpoint. It is not that the OEMs don't understand. So, okay, I am the first mover in enabling autonomous driving without high fidelity maps. In all our autonomous driving, we don't use any high definition maps or any high fidelity maps. But if you talk to any company like why high fidelity maps are needed, they will say from legal standpoint, I mean, it's necessary because what if your vehicle misses to detect XYZ things? So this is the state of the art, right? And okay, we have another solution actually we are working, and that is the reason why we are working on delimiters prediction, because detection is, I mean, if you just focus on detection, you're never going to, I mean, detection alone is so hard. Just imagine how hard the prediction would be. And the reason why no one has focused, I have not come across a single company that is working on the ability to predict delimiters. Why we are doing that? Because we have been working in Indian environment settings, and in Indian environments often these aligned delimiters are missing, so you need to have the ability to predict. This is why we have been doing delimiters prediction research, because in India, I mean, you would often find even the aligned delimiters missing in the environment. And since we have been focusing on that, we know that there is a problem, right? So we are able to identify the problem and have a solution as a result, because we know that this is a problem, right? And this is how we are actually, so this ability that we have with us to not just detect but predict delimiters, it allows us to get rid of the high fidelity maps. But while saying all that, just imagine, even on perception front, there are problems that people don't even realize, right? I mean, that there are these problems, right? And again, like, no one has even thought about the solution because they have not looked into the problem. They have not encountered it before, right? So imagine how many problems there would be specifically on the planning algorithms front. And no one, and this is the reason why people are talking about we need to build this XYZ simulator. It needs to simulate corner cases. How do you even know that a particular case is a corner case, right? Either you need to have a very intelligent reinforcement learning based, simulator built in, which is a very good, search algorithms which can, identify some, some particular, configuration of the vehicle and the environment, some particular state space configuration which identifies it being a corner case, and you have, that situation simulated, and you have, perhaps if you are using, some reinforcement or some IRL or some apprenticeship, then perhaps you can train a model to deal with those situations. But first, you have to, so just imagine the perception front, which is so apparent problem. I mean, that something can go missing in the environment. No one has developed a solution for it, right? Just to give you an idea, if we ignore our ability to predict delimiters in real time, even if we just forget that we have got that ability. So one of the instances of our delimiters prediction research is our lane direction generation algorithm, and there are so many videos on our website for that. Even if we ignore our ability to predict, we're still 6 times faster in the NVIDIA system, right? So this is roughly what we're doing on the perception front. And so the claim of the companies that they're going to be level 5 in 1 year, I don't think they understand what autonomous driving actually is, right? People like Elon Musk, they are very talented. I mean, he's very talented people. He's surrounded by awesome team as well. And see, in business, you have to make that claim, right? I mean, otherwise, who is going to listen to you, right? But often, like big automotives, these are the CEOs and manager level people who are making the claims that autonomous driving is. It's not that, I mean, see, our goal is to make autonomous driving not just possible in North America, but to be able to deal with the kind of stochasticity that you see in their traffic dynamics, so that we can ensure safety in Europe and North America, right? But even for us to accomplish that, it would take by 2024. Actually, to do it, at commercial scale, right? People who are claiming that they are going to be there next year, I don't think they have an understanding of the complexity of the problem that they are solving. So, and oftentimes either, they know it, but you have to make a claim. That's the nature of the business, actually. Yes. Yes. And you can look at. I mean, it's nothing against Tesla in particular. I think they already know that they have put just an autopilot system on road, and a company like that, they know like what they are currently offering, right? Maybe in background they are really building an awesome tech. But I have been, I recently followed, the talk by their tech lead, the transferring lead. Is at is Scaled ML conference where they demoed their algorithm that can predict the depth without using lidar. It's a stereo camera based. It's a multi-camera or stereo camera based system, but it requires hundreds and hundreds of gigaflops of compute power. So they have developed their specific hardware to do that, right? From power point of view, when you talk about level 5, for example, you can make $1 billion vehicle available next year, level 5, that crawls at 30 kilometers per hour, being able to deal with all the traffic scenarios. But if you take a commercial vehicle, right, and if you say that this is level 5, you not just have to take the algorithms, the complexity, but also the computational complexity. What kind of infrastructure are you talking about, right? And these are all the factors that you have to take into account. And it will take time to achieve level 5, but I think no company has even focused on dealing with traffic situations that are 10 times harder, where
They're testing, right? Unless that happens, how they're going to develop the tech, I do not know.
Yeah. So the one major problem is, the algorithms. I mean, you talked about the three major areas, right? The perception, localization, and planning. You mentioned that planning is probably the most difficult part, and if we make progress in that area, that means that we will be approaching a bit closer towards level 5. But you also pointed down the limitations where we had limited in the computer vision technology, about delimiters and things like that. And one thing just comes to my mind like almost randomly. So there's this guy called George Hortz. He's making probably about it, that's why you smile. So with comma.ai, he's trying to create a chip or a processor. I don't know how exactly it is, but he claims that you just fit it in the you replace the rear view mirror with it, and make a few connections, and any car would become an autonomous car. What are your thoughts about that? Because I don't know, I have no clue about the technology behind that thing.
Um,
Sure. So I answered questions about George Horse in two different interviews as well. So this will be a third time. I mean, so I don't want to be repetitive, but so George Horse has to use reinforcement learning to achieve what he claims. But even if he tries to do that, the problem is very hard. So, for example, what he's saying essentially is that he will be able to train a neural network in an end-to-end fashion to be able to train an autonomous vehicle to deal with any kind of scenario imaginable. Without reinforcement learning, it cannot be done. For example, let me give you an idea. Take a vehicle in a campus, retrofit it with cameras, retrofit it with all the compute hardware. Don't focus on the computational amount of computations at the moment. Just focus on solve the problem, right? Try to run a vehicle in a campus again and again. Try to collect data. Try to train the deep neural network. Eventually, you'd be able to train it, right? Now let's just take the vehicle off roads, where the vehicle had never been before during training. The vehicle will never recover from it, because end-to-end deep neural training is that this is the image, this is the action. Right? If you have not seen the image, you cannot know the action. The way to get out of that is using reinforcement learning, because reinforcement learning takes the future also into account. I mean, you use discounted rewards to actually train your system. So basically, in reinforcement, you have a state. In that particular state, your agent takes some actions. Once you take an action, your environment changes and you transition to a next state, and that next state gives you a reward. And using these reward signals, basically you learn like what are good actions and what are bad actions to make in a certain situation. So even if you are in a state that you had never encountered before, your system can still recover from it, because the problem is inherently temporal, right? It's a sequential decision making problem, right? So your agent can look into all the sections, all the actions that are available. Which best action to choose to actually make a transition to a better state from where you are right now, right? So with RL, it is still possible, but still, I mean, you have to have, as I mentioned, you need to have a very good simulator, and you need to have very good search algorithms as well that can find because training a system end to end using RL is also not an easy task. First, you have to collect the data. You have to be very exhaustive in data collection. You have to be very exhaustive in the random walk. You have to even if you accomplish all that, there would be corner cases, and then you need to have very good search algorithms as well that can figure out the regions in the state space which are corner cases, and you then try to focus on that. This is very complex one, and so essentially you're saying remove perception pipeline, note that even most of perception algorithms are end-to-end deep learning problems, right? So it's not that deep learning is not used in transferring, it is used heavily. For example, you can use reinforcement learning to augment an existing control. For example, in one of my primary motion plan, there are 8 different reinforcement learning agents that are acting in parallel with each other, right? So reinforcement learning is you can use to make better decisions, to augment an existing controller, to augment an existing planner. For example, let's suppose you want to be able to decide how to overtake on typical 2-lane roads. Okay, let's use RL. An RL agent would be able to dictate when to initiate overtaking, when to terminate overtaking, and if you terminate, how do you terminate overtaking? So this is what TSN, we call it tight space negotiator, which is a part of multi-agent intent analysis negotiation framework, and a parallel framework to TSN is our overtaking framework that we are currently researching on, right? So you use reinforcement learning over there actually to decide all these steps. But if you're saying that I will just use a single algorithm embedded in my chip that will learn end to end everything from perception to planning to everything, it's a very you're playing with lives. I mean, for example, even if you manage to, it's not that your vehicle won't run. For example, even with end-to-end deep learning, you can make cruise autonomous driving vehicle that will never have to change lanes, right? Because if you try to change lanes, there can always be scenarios where your vehicle will find it and never encountered in its training data, right? So you'll be getting stuck. The way to get out of that is again use end-to-end RL for cruise autonomous driving, right? And perhaps your vehicle would be able to execute overtaking as well on multi-lane highways. But to say, I mean, bring a very good media person and say this is autonomous driving. It's not autonomous driving. It's just one algorithm that is intended for, just like, for example, I explained, I mean, you can have a very good overtaking RL agent that decides how to overtake, when to overtake, if terminate, how to terminate. But can I maybe one day I call you, just take a ride in our vehicle, say this is how the vehicle overtakes. This is one algorithm I'm demoing to you. This is not entire autonomous driving. Entire autonomous driving is a set of complex, all the different complex scenarios, and you having the ability to actually deal with all those complex scenarios. With end-to-end learning, it's not feasible. Few years from now, when you have that kind of compute resources and the data collection power and the very intelligent search algorithms, because George How's claim is end-to-end training, right? Label data, maybe for perception tasks. Now he has diverted. Maybe I do not know why. Because if he was doing end-to-end RL, then he wouldn't be needing labeling, right? But he requires labeling as well. So he's not even thinking end-to-end RL. So what he's doing is very complex for me to answer what he's trying to achieve. But for some use cases, yes, it may work, but it is not autonomous driving, right? For example, you can gather 4 people. One one person who has control expertise, one person who has computer vision and deep learning expertise, one person who has localization expertise, and one person who has planning expertise. They may have masters or PhD degrees. Bring them together, give them enough resources, and they would be able to build an autonomous driving vehicle in perhaps a month, right? Building an autonomous vehicle is not hard. What autonomous vehicle achieves, that is the question, right? What level of autonomy, what kind of conditions is it able to deliver? So this is a very tough problem. So I will restrict my discussion about George Horst to this. I mean, it's not intelligent way to go, at least as of now. In near future, you need to have very good team, very good RL team to develop some of the algorithms if you try to achieve end-to-end RL.
Okay, and the main disadvantage is it the complexity of the algorithm, or is it computation, which is a main barrier to his approach of going with it?
The approach is flawed. That's the major limitation, right? The entire approach is flawed. I mean, for example, just recall the discussion where I mentioned end-to-end training without using reinforcement learning. You mount your cameras, the vehicle will see what the environment is, you will give it a steering and the accelerator and the brake command. These data would be recorded. So your vehicle will record end to end. In this situation, you applied this control. In that situation, you applied that control. That's why his claim also says you need trillion miles. I mean, most of the companies are claiming you need trillion miles. So any person who thinks end to end deep learning, they will directly claim trillion miles because they know you need to encounter every situation. Now, if you're using RL, then because of this temporal nature of the problem, from state to you pick action to make a transition to next state, get a reward. From reward, you learn good actions. You can get out of the states that you have not seen during your data, during your training, in your training data, right? But without using reinforcement learning, end-to-end reinforcement learning, how that is even possible? It's a flawed approach. Even he should know it's a dead end, right? If he continues through that, but it's very easy. I mean, I don't know whether they're still continuing their autonomous driving operation, because to the best of my knowledge, their autonomous driving division shut down. They are working on ADAS, something like that. At the moment, I'm not aware whether they're still continuing their autonomous driving operations. I did know they had $3 million in seed funding when he began Comma.ai. What is happening right now? It is because, I mean, it's very glamorous to actually claim that, I mean, single chip, and that's why, I mean, that's immediate attention also that is going to come along the way. But the approach is not, I mean, for example, if you want to make an end-to-end campus driving vehicle where everything can be, seen, even if there's something happens that you have not seen in your training data, how you overcome that situation, I do not know. If you do not use any other algorithm as well, just imagine end-to-end training of a network, input images to the recorded actions. That's it. If you have no recorded action for a particular state, your vehicle will apply a wrong command. The moment you apply the wrong command, your vehicle will deviate from the ideal trajectory that you had shown during your training. Once it starts deviating, there's no way to recover for it unless you have used RL. And his claim, I never saw RL in any of his discussions. I had seen his interview as well way back. I mean, when the interview happened, there was no mention of RL at all. So it's pure end-to-end, deep learning based training. So the approach is flawed.
Yes. Deep learning is also a black box thing, and relying on, we don't really know how, it generates the features or things like that for.
And if you use end-to-end deep RL based solution, yes, I mean, it can be achieved. As I said, like for some conditions you can achieve, but then you need really awesome team to actually develop many other things that would be useful to solve the problem. Claiming it that you alone will just keep on recording the data and solve it, I don't know how much time, because then it's a question about getting such kind of a data and processing it. We are talking about processing, some significant billions of kilometers, right? I mean, so then it will become a computational question. Yes, sure, please continue. Yes. For example, let's suppose you build an end-to-end RL agent for one task. Now there are hundreds of tasks. You build end-to-end RL agents, end-to-end deep RL agents for hundreds of those tasks. One day you can merge all those, right? So there would be perhaps start merging. Maybe there are 5 left. After 5 years, only single one left. because it has a company, it has a comment, it is basically it's able to do all the tasks of those 100. So it's a single unified, very big, deep into an RL agent, which is represented by a neural network, right? So that can be achieved, but as I said, it then becomes a question of number of the data points and the amount of compute resources that you have, if you do not use any intelligent search or anything like that.
I really hope that you enjoyed this particular conversation and it helped you in some way, shape or form. If it did, make sure to hit the subscribe button and the notification icon or the bell icon so that you can get notified on time whenever the next part is out. Also, it would be really great if you could give me your feedback in the comments below. That would really help me improve. I'm uploading small clips of the long podcasts on a regular basis on platforms like LinkedIn, Facebook and Instagram, so make sure to follow me on these platforms if you're someone who cannot take out time for the long episodes. The podcasts are also available on all major podcast platforms including Spotify and Google Podcasts. So if you're someone who prefers to listen to podcasts rather than watching full-length videos, make sure to follow on your favorite podcast platform. Thank you very much and see you next time.